We have seen what is support vector machine and what is margin and how we will go forward in mathematical formulation. So we have seen that this is the hyperplane and hyperplane can be represented as wx plus b as 0. So remember, because this is mathematical multiplication of two vectors, one should be vertical, another should be horizontal. So sometimes we'll be writing W transpose rather than W. But value will not change, it is only for multiplication purpose. So hyperplane is represented by W transpose into x plus b as 0. And let us say all these are plus 1 classes. That means the label is plus 1, target value is plus 1. So this border on which there are support vectors, these are all support vectors, and this we call as margin. So this equation is W transpose into x plus b is greater than plus 1. So all the points, when you substitute any point in this equation of wx plus b, it should be greater than 1. And when you come to this plane, for all these points, W transpose into x plus b is less than minus 1. So for all these points, it will be less than. It will be equal to 0 here. It will be equal to 1 and it will be less than minus 1. So these are the three equations of the lines. So what is our problem in SVM? We want to find the vectors W and B. These vectors, or W is of course, B is not a vector, such that the target value into W transpose into xi plus b should be greater than or equal to 1. Equal to 1 for support vector. Now see, suppose it is plus 1 category. That is target value is plus 1. Then this value plus 1 into, for positive classes, W transpose into xi plus b is always greater than 1. Always greater than 1. So 1 into greater than 1, it will be always greater than 1. Similarly, when it is negative category, minus 1, so minus 1 into any value below this line will be less than minus 1. So minus 1, minus into minus plus, so it will be greater than or equal to 1. So we formulate that target value into W transpose into xi plus b is greater than or equal to 1. Equal to 1 for support vectors and greater than 1 for the remaining points, whether positive or negative. This is condition 1. And for optimal plane, we want this margin to be maximum. This margin to be maximum. So let us consider 2 points. This is x2 and this is somewhere here x1. I want to calculate this difference. I want it to maximize this. Maximize d. What is the d? D is the distance between these 2 points x2 minus x1. But this is not a perpendicular distance. So what we can do is we can calculate this distance and we can project it onto a vector which is w. So to make it unit vector, we'll divide this w by the magnitude to make it unit vector. So what we do is x2 minus x1 into w by magnitude of w. This is equal to magnitude of W into Wx2 minus Wx1. Now let us come down here, we'll write it here. 1 by, I want to maximize, I want to maximize 1 by magnitude of W into Wx2 minus Wx1. If you remember, x2 belongs to the positive class. That means Wx2 plus b is always, because it is support vector, it is equal to plus 1. It is equal to plus 1. That means Wx2 is equal to b minus 1. Similarly, x1 is negative class, Wx1 minus b is equal to minus 1. So Wx1 is equal to minus 1 plus b, or b minus 1 plus b, right? So minus, let me write it here, plus b. So it is minus 1 minus b. Substitute that. I want to maximize 1 by magnitude of W into Wx2 is b minus 1 minus 1 minus b minus 1 minus b. So minus into minus plus b, and minus b gets cancelled. Sorry, this is 1 minus b, not b minus 1. So 1 minus b plus b and minus b gets cancelled, and 1 plus 1, it will be 2. So 2 by w. So the SVM problem boils down to an optimization problem where I want to maximize 2 by magnitude of W such that are subjected to, with a condition that Ti into W transpose into Xi plus B is greater than or equal to 1. So I want to find out W value for which fulfills these two conditions. One thing is 2 by magnitude of W should be maximum, and this should be fulfilled. So for mathematical convenience, what we do is, instead of maximizing 2 by magnitude of W, will take half, minimize the half of magnitude. And for mathematical convenience, instead of taking W alone, because magnitude is calculated from the square, let us take that as W half W square. Because W is a vector, instead of writing W square, I will write W transpose into W. So the SVM problem can be stated in a single line. We want to find W and V such that the hyperplane which minimizes half W transpose into W with a condition subjected to Ti into W transpose into Xi plus B is greater than or equal to 1. This is SVM mathematical formulation.